Hi, we're here to take a look at our pre-production planning of parts for our manufacturing department. We do some pretty unique things here in integration of SPC and other quality management tools that really set us apart from what our competition is doing. I'm here with Derek, our manufacturing manager, and Kevin, our quality assurance manager. They're both going to give us a little bit deeper dive underneath the covers of how we pulled this all together.
Upon receiving a purchase order from our customer, we'll pull a team together to review the drawings, assess the processes, go through a FMEA, and really dive into the details of the drawing and what the customer is after, and try and understand that to the best of our abilities to produce a product that meets the customer's expectations. So I'm going to pass it off to Kevin, and we're going to dive more in depth into this review process.
So once the review starts, the process is defined. We've reviewed the drawing, determined what the manufacturability of the design, and if we have any issues, we'll work with the design engineers of our customer to find a solution for a better manufacturable part. Once we complete that portion, we then finish the process flow. From that point, we go ahead and do the FMEA, and it drives us down into a control plan. All right. Once the control plan is defined, then we'll go ahead out and start to put the mechanics together for the inspection and the quality requirements, along with working with the manufacturing team to ensure that we're aligned with the operations and what the outputs will be from them and the inputs they need from us. So once that's completed, we'll create a inspection plan, which will include a inspection plan for the operator at the machine, and also any kind of data that's going to be collected from a CMM inspection report if required. Behind me here is some of the results of that. This is essentially a database coming out of a CMM. And here is what we talked about here is a integration of the inspection plan that the operator will see at the machine. These are all the features that the operator will be responsible for, right? Also, for the operator, at one click, they will have the ability to review the control plan. Now, control plans are living documents, so when we first start off with, we're going to do our best from the FEMA, but we're going to learn something as we run the part and make adjustments. So essentially, we're going to be, at each operation, each step, there will be instructions for the operator on what they're going to be looking for, what the tolerances are going to be, and what mechanism they're going to use to control the process. And that could be like gauge station, the spec plan we just looked at, or if there's a CMM program available. Also in there, the criteria for inspection, what they're going to do, 100% inspection on everything, or they're going to do the inspection based upon how the process is running. So all our jobs are based upon a CPK. So once we're looking at the CPK in the control plan then will match up and say what your inspection frequency will be. So if you're at a CPK and certain feature of less than 1, you're going to be at 100% inspection. If you're greater than 1.33, your inspection frequency may move up to 4 to 10, depending on the complexity of the part and the risk associated to the customer and MCF.
So Kevin, with that, and you're talking about that control plan and these features, you're speaking a little bit about statistical process control. How does that all integrate? Where do those CPK numbers, where would the operator find that data? How are we using it in real time?
All right, so here is a pretty complex part. This here has over 630 features. So it'd be pretty difficult for an operator to maintain the quality level and understand what's going on if they were only getting printed out tablets of information. Here, so we have a database here of all the features that are being collected, and you can see the different colors. Right now we see nothing in red, and we don't see anything in purple, but we do see something in yellow. So I'm going to open up just one just to see what we have here, if it's going to let me. All right, so here, down at the bottom here, is that CPK, and you can see this feature 239, is running at a CPK level of 5.05, which is pretty outstanding, right? So they would be at the higher level inspection. We're looking here at something that's yellow, right? CPK is still over 1, which means it is capable, but it's just running into a low level of the tolerance, which if we go down to our statistics, we can see that the CP, which is how well controlled the process is running at 2.39, which is well above 6 sigma.
How are we responding to that data then? So if we see this, you mentioned some colors, you mentioned red, purple, yellow, and green. How is the operator use these visual tools to respond in a real-time environment on the manufacturing floor?
Well, let's first talk about why it is turned yellow and why we have control limits here. Now, because it's a manufacturing process and we want the ability to be able to adjust as we go, we're not calculating or allowing the data to calculate the control limits. We are setting the control limits right now at 75% of the spec limits. So as soon as it goes outside that 75% of the spec limit, then the operator is alerted to take a look at the data by it turning yellow. Here they'll take a look at this data here and assess that we're running pretty tight with a CPK of 1.02, but the CP is 2. We may not take any action because of the level of the CP and how well it's being controlled. But he is alerted to that. Red would obviously mean that it's out of spec and action is required immediately. That would drive the operator to quarantining the product and going back and quarantining any product that was manufactured prior to the last inspection. Also, if it's purple, purple means it's outside its trend requirements. That means it's not meeting a CPK level of 1.33. Once again, that is identified to the operator that he may have a potential problem. But here you can see that the CP is above 1.33, right? So we may not take any action there either. So we're lucky enough to be looking at a database here that the data is pretty well controlled.
So this database that we're looking at, Kevin, there is an incredible amount of data that's shown before us. How is this all being aggregated and communicated? So we understand how this is presented to the operator. We understand from what you're saying what this information means to the operator. How in the world are we able to collect so much data in real time and feed that to the machining center so that we can have a more iterative process and building quality into what we're doing versus batching work and it just seems like there's a ton of stuff here, and I think it's probably, if you're taking your first look at this, really overwhelming to understand where this is all happening. So how are we collecting all of this?
All right, so there's 2 ways. First of all, we have an inspection plan for the operator, right? As soon as they populate their inspection and hit the finish button, it will go ahead and populate the database here, right? And they'll be able to look at what they actually inspect and what is the trending data. Also, if you look up in here, we're controlling things here. We have the lot numbers involved and all the transaction, all the traceable numbers being recorded for each point, and then a sequence number. The sequence number is the day, the month, and the day and the number of part produced. That way we control the product the whole way through the process, and if we have to go back and look at anything, we can correlate the data to the actual part, which is very important. Now, product like this that's so complex that goes into the CMM, once the CMM is completed, it is an inspection routine, that data is then available for the operator and it goes right out to their station. So they're getting that data real time, right after the inspection is completed, that they can react immediately to what the data is telling them.
So what you're saying, Kevin, is that we have a 2-pronged approach. We have the operator that's collecting a small portion of information that they're collecting at the work center. And then we're also feeding work into a CMM lab that's aggregating hundreds of data points in real time and then feeding that data live back to the operator. Is that what?
That is correct.
Okay.
Right. So The other portion of that, if you're looking at this, the complexity of 600 and some features, and a drawing that's probably just as complex, or is as complex, we also provide the operators what we call a data map. Right? The data map then describes each of the numbers on that chart, the location of them, and their label. So as once they see something that's out of control or out of spec or something they need to adjust, they'll be able to go into it, find that number, and then locate that number based upon the feature. You can see there's quite a few numbers, and pinpoint that exact point that they need to take a look at or adjust. Right there it is.
So what is that feature?
That feature is a part of a radius, right? So we're taking profile points along that radius, now putting them that way.
There's a ton of things going on here. How do I look at this and go, there's value here that's translating back that's meaningful to me?
Well, it gives the customer confidence that we're doing our utmost to ensure that they're getting the part they require from the design. And so that means that they can ensure their fit functional portion of the assembly or whatever the product going into will meet that requirement. Mm-hmm. So it carries a lot of weight as far as being ensuring that the product they're getting is what they want and meets those requirements, and they will not have any issues in their assemblies.
And why does this type of process where we're looking at using real-time SPC, so we have an integrated SPC system on our manufacturing floor that's extremely unique to a CNC metal cutting environment that's a high mix, low run type of product grouping that moves through the shop? Why does this save us money, or how does what we're doing actually reduce costs versus more traditional means of quality verification and control?
Well, if you're talking about inspection versus quality control. Inspection means we're going to check the parts after it's already made, and that means that we may have more fallout at that point and a lot more inspection to perform. In this way, we're verifying the product during the process. We're not inspecting the product. We're verifying the process is yielding the product that we desire to produce. So we're measuring the process more so than the part itself. And that's what's key, right? So if we have our process under control, we're going to guarantee that the customers are going to get the product they want.
Right. So a lot of customers, they don't just want the product, they want the paper to go with it. And I noticed when you were going through and showing some of the traceable factors for the parts, we have things like lot numbers, we have predefined routes, or not really predefined routes, but we have process transactions that are out there that are traceable. All of this detail is coming together, and we're able to pull this all together in the end and deliver not only a product, but sometimes what's more important than the product itself is the paper that goes with it.
So everything we do is driven by lot numbers. So as soon as raw materials comes in, it is received and immediately gets a lot number. And all the paperwork associated with that raw material is then scanned into our system under that lot number, controlled as such. At that point, when the product is ready to go and the job is ready to start to run, a transaction which has all the predefined codes as far as each step of the process that we already defined during our initial kickoff, where we did our process flow, our femur, and also then the control plan. That it goes down, flowed out, and a lot number is then assigned to pull that material from stock. We pull that material, start that transaction. Now we just associated the lot number of the product in process with the lot number of the raw material. So now we have a traceable connection, right? Every step of the way down through, we are controlling the process one step at a time for each of the manufacturing or outside processes or inspection steps down through the transaction. Once that transaction is completed, another lot number is generated at the final step. So now we have traceable back from the lot number we provide our customer that traces back all the way from the production lot number and how it was produced and when it was produced, all the data that was collected during that process, or then back to the raw material will take us back to the mill and exactly where the material was manufactured and melted. So the whole way through the process is a unique connection that ensures that we have traceability back to everything we do and how we do it. So not only do you get it all the way to the lot number that you receive from your certification, but you have that whole link from beginning to the mill.
Yeah, there's a lot of moving parts to what you just saw. We're going to go out and see how all this comes together and makes us your best choice for precision CNC machine parts.